Okay, well, I did a bunch of hacking on this light here, this commercial electric exterior LED wall pack. I'm not sure why they call it a pack, but this is the light that I have on the back of my small shed out there that we saw in the other videos, building one. And he is an RFI generator on 10 meters. So what I've done, we've talked about these little RFI EMI filters that they call them, I guess. I've used these from time to time with pretty good success. I shopped around for these recently, and these are smaller ones, but they were pretty cheap. Got them on eBay. Fortunately, I only got 4 of them. eBay shipped them to my old house. Good thing I know the guy who bought my house. I guess my eBay address wasn't updated. In any event, I took one of them and put them on the input side earlier, and it did reduce the noise about halfway, but it didn't get rid of all of it. Then I got to thinking, it says, well, it's actually switching on the secondary side into the LED array, which is way too bright to look at. So I have blocked with a box there. This is a constant current module, 230 milliamps at 36 to 55 volts. I guess LEDs need constant current, and that's what that guy does. He's a potted module, potted with black RTV. I opened him up. So I thought, well, I would trim some wires down and put one of these modules, these RFI EMI filters, on the output of the switching module into the LED array. And so what I did is I hacked a bunch of wire up. These wires are way too long, too much antenna for me. So I cut everything back and made really short leads. I'm living on safe here, but I'm a clip lead kind of guy. And so I have one of these modules on the input side, 110 volt side. I have the cans touching, and then one on the output side. And so what we're looking at here, this is the background noise. It's about S4, maybe S4.5, I would say, with the light running, with both of those filter modules in line. So if I disconnect the light, bang. So it didn't drop all the way. I would have expected it to drop all the way, but it's about a 3.5. So 3.5. Let's try that again. 3.5. Get over here, blue wire. Okay, light come on. I have to have this cardboard box there because there's the light sensor. So I need to block the light. So it's in line now, and I guess it is about 4.5. I have some extra lead length here. Maybe this is what's causing it here. Let's take that off. Still about 4.5. So earlier it looked like it reduced it, eliminated it altogether, but it doesn't look like it's quite doing it. Maybe once I get that tidied up, it will. 3.5. Put the light back up. Yeah, hi Casper. Okay, we're back to 4.5, almost 5. But what I wanted to illustrate here is the filters. To prove they're doing the work, what I'll do is take the secondary one, or the one on the output of the module, going to the LED array over here, and I'm going to short out one of the legs. Oh, that's bright. I'm burning my retina. Typically, you would just bypass. I'm just shunting around the EMI filter for the output, the DC side, into the LED array. So that's red to red. And then we should see this signal go up. And we do. Look at that. So now it's up to S7. And you can see the noise here on the band scope. 6.5, 7. And then you can hear it too. Pretty obnoxious. So I really upset the filter just by shunting out one side of it. When I try to shunt out the other side, it doesn't seem to make the noise any worse. So basically, just by shunting out one side, eliminated the filtering altogether anyhow. So let me get on the other side here. Okay. And I'm just going to short him out, which will effectively remove this EMI filter from the secondary side, or what I'm calling secondary is the output of that DC module, constant current, and it's still about the same. 6.5, 7. You can see the noise bars. And so the filter on the output side of the module is definitely working. I take them off. I'll do this here without blowing anything up. Remove the antennas. And then what do we have here? Yeah, back to 4.5. And a nice dark blue band scope. So it's working.